Okay, so we're gonna look at this question. So this one is actually the past semester exam paper. So let's see what year is it. So this is July 2021. Okay, this is July 2021, and the questions for regression analysis is in question 2. So bear in mind, sometimes in terms of the format, it doesn't follow exactly year to year. So normally, sometimes it is in question number 2, sometimes it's in question number 3. So it depends. Alright, for this one, it is in question number 2. If everybody can see the screen, okay, boleh nampak eh? Okay, let me get some information. Sekejap eh. Okay, right, so this is the data that you have. So you have here, in this case, a study was conducted to determine the relationship between a driver's age and the number of accidents he or she had over a 3-year period. The data collected for 10 drivers are shown below, and then you have the data given, the driver's age and the number of accidents occurred for the drivers, right? And then by assuming that the driver age and the number of accidents is normally distributed, the data were analyzed and the output is indicated below. So they bagi output dekat sini, so they bagi the output of the coefficient first, eh? So they didn't give the model summary, so that means you don't know the value of the correlation and so on, eh? So basically, when you talk about regression analysis and correlation, they give you the same data set untuk kedua-duanya sekali. So that means this data set can be used for the correlation and also for the regression analysis. Okay, one thing that you need to know is that even though dalam correlation analysis kita tak perlu nak identify the dependent variable and independent variable, but since the data is being used also together with the regression analysis, you need to identify the independent and dependent variable. Okay. Okay, alright. So in this situation, what you need to do right now is to determine the predictor and the response variables. Okay, you have the predictor and the response variable. Okay, sometimes we get confused with this particular terms, because normally we are using the independent and dependent variable, right? So there are several things that you need to understand in terms of the terminologies used in regression and correlation analysis, right? So you already know that the independent and dependent variable. So what is the other name for independent variable? So the independent variable also sometimes called as the exogenous variables. Okay, exogenous variable, or sometimes also called as the predictor variables. Okay, so predictor variables. So biasanya predictor variable ni adalah yang kita nak nilai yang kita boleh gunakan untuk kita predict something. Okay, that's why it is called the predictor variables, right? So in this situation, if you are asked to give to identify the predictor and the response variable, so response variable ni adalah dependent variable. Okay, response variable adalah dependent variable, or sometimes also called as endogenous. Okay, dia ada exogenous dengan endogenous. Okay, so in this situation, kalau you tengok dari segi variable name, kita ada ni. So we have what we call as the first one is for independent. Saya nak kecilkan sikit lah, yang ni boleh nampak sikit. So we have the independent variable, or sometimes also called as the predictor or sometimes also called as the exogenous. Okay, exogenous. So this is for X. Okay, untuk yang Y pula, okay, untuk Y pula kita ada so this is for Y. So for Y we call this as dependent variable, or some other names is the response variable. Saya terbalik kejap kita terbalik respon dengan predictor ni. Respon X kat sini. Betul Okay, response variable, or sometimes also called as the endogenous. Okay, or sometimes also called as the outcome variables. Okay, sini outcome variable. Okay, kalau yang ni pun ada juga yang dipanggil sebagai input variable So input variable, so boleh juga so input variable and outcome variables. Okay, macam mana kalau katakan yang exogenous dengan endogenous ni, macam mana kita nak tahu yang satu tu X, satu untuk Y? So you tengok so for the exogenous dia ada huruf X nya. So you know that this is for the X variable, that is independent variable. So this one is endogenous. Of course, kalau this one the exogenous will be the independent, so this will be the dependent variable. So in this situation, if you are looking at this data, okay, the first one they ask you to identify the predictor and the response variable. So that means the predictor is the independent variable and the response variable is the dependent variable. So you can identify the predictor and the response variable by logic, looking at the data set, the data given, so which one depends on this one, or you can look into the question itself. Okay, into the question itself. In the table given here, you already see that age is in the model. So whatever that is written in the model in this box, so this will be the independent variable. So this is the predictor variable. Another way to look into the to identify which one is dependent, which one is dependent. So you look at the last question. So the last question says predict. Okay, the last question states predict the number of accidents, but for a driver who is 30 years old. So the given value here is 30 years old. So this is age, right? So the given value will be the independent variable. Okay, because this is the value that we can manipulate it. Okay, we can manipulate the explanatory variable. So this is what we are looking for. This is the explanatory variable, right? Right, so the age is the independent variable. So ini adalah satu cara lagi untuk kita tentukan which one is the independent and which one is the dependent variable. Or in this sense, dia gunakan terma, predictor and response variable. So the answer here will be for the predictor, you have age. Okay, so age will be the predictor variable. Right, and then for so in this case, kalau nak lebih tepat, kita letak driver's age lah So we have the driver's age. So driver's age will be the predictor, and then for the response variable, this will be the number of accident. Okay, so this will be the response variable. Okay, so we have the predictor and the response variable. Okay, next is to compute the Z value. Okay, the value of Z. So this is the beta coefficient. Okay, this one is not in discussed in the YouTube so yang ni tak ada dalam YouTube tu, so you have to bear in mind macam mana kita nak kira. So in order to find the beta value here, so this is the standardized coefficient of beta. So this one is the unstandardized coefficient of beta. So yang depan ni unstandardized. So the one that in front here, the B here, will be used in building your regression equation. But this one is normally used to see the impact. Okay, the standardized impact. Okay, the effect of the variable age on the predictor, the response variable. Okay, so because this one is unitless. Alright, so how are you going to find the value of Z? So this one you have to calculate using the multiplication. You have to first find the standard deviation for the independent variable and the dependent variable, and then you multiply with the unstandardized coefficients. Okay, so in this situation, apa yang perlu you buat adalah you perlu dapatkan dahulu dia punya standard deviation for the driver's age and the standard deviation for the number of accident. Okay, how to do that? So you can just create using your calculator. So you boleh gunakan calculator anda untuk build this ataupun calculate this values. So macam mana kira standard deviation, you boleh check dekat dalam YouTube channel saya. Okay, saya akan buat secara ni so kalau boleh saya buat kat sini lah So let me just put use an Excel je lah, senang So let me try to get an Excel sheet. Hopefully line tak okay lah So kadang-kadang dia slow Sometimes it's very slow. Out there? Tak apa jelas Okay. Sebab memang kadang biasalah UiTM ni kan. Faham lah. Okay, saya akan cuba dapatkan data dia. So 10, 24, 16, 18. Nak keluar apa lambat 10, 24, 16, 18, 23, 16, 18, 23, 16, 18, 23, and then you have 27, 30, 32, 24, and 28, 21 28 and 21. Okay, and then the second one you have 32520. 32520, and then you have 11103. 11103. Okay, this is for the X, and then this one is for the Y. Okay, you nak dapatkan dia punya standard deviation so saya dapatkan dia punya standard deviation SD saya tekan SD je lah. So STD okay, you want the standard deviation, this value. Right, so you get this value, and then this one saya nakkan standard deviation to this one Okay, so this is the standard deviation for these two values so that means in this case, and then kita tengok balik dekat kita punya data. So in our data, so we have the value for the coefficient H will be negative 0.216, right? So you have the B equal to negative 0.216. Okay, so kalau saya nak run this one first, tak apa, saya try run this one dulu, dapatkan the regression equations. Okay, let me just run this thing. Alamak, tak adalah pula. So, okay, saya ambil dia punya slope. And then for the slope ataupun dia punya B, B coefficient, so you have slope okay, you ada data Y. Okay, comma. Then you ada data X. Okay, you get negative 0.167. So 0 negative 0.16. Pasal apa lain? Silap data ke? 16, 24, 16, 18. 16, 24, 16, 18. 16, 24, 16, 24. Sini 16 16 Sorry. Okay, so you get 216 sama So the value is negative 0.216. So over here also negative 0.216. Right, so let me just make it this bigger. Saya rasa macam tak nampak dia you all ni. Right, so nampak kan? Okay, you have the value for the X. So yang ni kalau nak kira dia punya, if you want to calculate the standard deviation, you can use your calculator. So the method to calculate the standard deviation manually using your calculator is in my YouTube channel. So you boleh tengok satu video, tapi tengok dekat dalam yang easy stats So ada how to calculate the standard deviation for this one Okay, untuk satu-satu variable. Ataupun you boleh kira secara manual menggunakan formula summation of so this one will be 1 over the square root of 1 over n minus 1 summation of x square minus summation of x and then square the whole thing divided by n. Okay, so you boleh dapatkan guna yang tu So this is the standard deviation for x and this will be the standard deviation for y and this will be the coefficient So coefficients untuk standardized unstandardized coefficient yang kita dapat daripada output kat sini. So we have this output, right? So in this case, if you look through this one, so this value is actually, kalau tengok dia punya ST, kita boleh tuliskan dia punya ST dekat sini. So this is the ST. The standard deviation will be equal to 5.27, 5.28 lah So 5.28 kita ambil 5.28 ataupun kita nak lebih tepat kita akan ambil 4 titik puluhan so 5.2799 okay, ambil 2799 and then for the second one, so this one is SD equal to untuk Y, so we have 1.5492 1.5492 1.5492 okay. So in order to calculate the value of Z over here, what you need to do is just simply take the ratio of standard deviation for X divided by standard deviation of Y and then multiply with the data over here, so the B coefficient. So what you need to do is just simply taking, so for Z over here, so to get the Z value, so this is just simply equal to, you take this one equal to the standard deviation for X and then divide by the standard deviation for Y and then you multiply with the coefficient, right? So this will give you the result. So the value here is 0.73624. Okay, so you can dapat negative 0.7362. Okay, so that is the value for the Z. So kita boleh tulis dekat sini lah. So saya tulis dekat sini. So in this case, to calculate the Z value, so Z is equal to, so you get the SD for X divided by SD for Y, and then multiply with B. Okay, so in this case, what you have here will be equal to 5.2799 divided by 1.5492, and then you multiply with negative 0.216. Okay, so you will get this to be equal to, so in this case, kalau you kira ni, you akan dapat bersamaan dengan berapa tadi? Negative 0.7362. Negative 0.7362. So that will be the value of Z. Okay, so itu caranya untuk kita dapatkan nilai Z. So you have to find the value of the standard deviation for the X variable, and then find the standard deviation for the Y variables, and then you take the ratio of these two values, and then you multiply with the value for the beta curve, the standard unstandardized beta for each, right? So that will give you the Z, or what we call as the standardized coefficient. Okay, so this is X and this is Y. Okay. 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 Okay, boleh. So in this case, macam mana kita nak explain? So basically, normally in the standardized beta is being used if you have a multiple regression. Okay, so in terms of multiple regression, because you want to compare the strength of several independent variable and to see which variable has a more impact on the response variable. So itu yang selalunya kita buat lah. Tapi kalau katakan untuk satu ni kita just terangkan lah apa yang berlaku. So because in this situation it is being standardized and so the variance is equal to 1. So that means the impact, the unit of changes is 1 to 1. So basically when we talk about the explanation in terms of the value obtained here, so this is 0.7362. So what you can say is that for additional unit increase in the age, okay, additional unit increase in the age, the number of accidents will decrease by 0.763 the impact. So this is what the changes will be. So basically kita tak boleh nak explain sangat benda ni kalau katakan dia is a single value, so is not common. Okay, in real research it's not common to explain the standardized beta if you only have one independent variable, because normally the standardized beta is being used to compare between independent variable and to see which variable has more impact. Okay, the one that have a higher value, that will give you a higher impact regardless of the sign. Contohnya kalau katakan you ada 0.73 dengan 0.93. Okay, mungkin ada satu lagi variable, dia punya nilai standardized beta adalah 0.93. Of course, the one that have a higher value will have a more impact on the response variable. Okay. Right, so that is in terms of the explanation for standardized beta. So hopefully boleh naik. Okay, so that is how you calculate the standardized beta value. So first of all, you need to find the standard deviation for both the x and y, and then use this standard deviation calculated and take the ratio and multiply with the unstandardized coefficient to get the standardized beta. And of course, kalau you tengok kat sini, kenapa tak ada dekat atas tu So untuk constant, kenapa tak ada standardized beta? Of course, they don't have the standard beta because constant is just a constant. It doesn't come from the data itself. Dia tak ada data. So kalau tak ada data, macam mana kita nak cari dia punya standard deviation kan? So this one is basically memang tak ada lah. So untuk yang constant tu, there is no standardized coefficient. So jangan pula tanya macam nak kira pula standardized coefficient untuk constant. Sampai ketua lah tak dapat. Saya pun sampai pencen pun takkan dapat lah jawapan untuk yang tu. Okay. And then the next one, they ask you to state the value of the slope. So and interpret the meaning. So value of the slope will be the coefficient under unstandardized coefficient. Okay. So remember, so unstandardized coefficient give you the value of the slope. The standardized coefficient give you the impact. Okay, the effect of x on y. Okay, so that is the difference between unstandardized beta dengan the standardized coefficient. So that means in this situation, kalau nak tengok standardized beta, dia melihat pada impact kepada dependent variable, manakala yang unstandardized coefficient dia melihat kepada perubahan apa yang berlaku. Okay, berapa banyak dia berubah. Okay, so how to interpret this value? So kat sini nilai dia apa tadi? Negative 0.216, negative 0.216. So in this case, the value over here okay, you have B, the slope coefficient is equal to B negative 0.216. So how to explain this one? So this is just simply you can explain. Okay, this is in general form. Kalau tengok dalam video tu saya tunjukkan macam mana explain. Okay, for each additional unit ataupun kat sini additional. Kalau kat sini unit untuk driver's age adalah year. So each additional year ataupun for each additional 1 year increase in driver's age, then Y. So what is Y? Y is number of accident, right? So number of accidents will decrease. Okay, kenapa decrease? Sebab nilai B adalah negatif. Okay, number of accident will decrease by berapa unit? So by B unit, by 0.216 accidents. Okay, so that is how you interpret. Okay, so the value of B is negative 0.216. So what you can just say, for each additional 1 year increase, so 1 unit increase, so for each additional, the general form will be, for each additional 1 unit increase in X, Y will decrease or increase by B unit. Okay, itu in general. But this one kita dah tukar berdasarkan kepada kita punya soalan. Okay, so soalan kita ada driver's age dengan number of accidents. So we change this into, for each additional 1 year increase in driver's age, number of accident will decrease by 0.216 accidents. Okay, so why decrease? Because the value of B is is a negative value. If the value of B, the slope coefficient, is equal to a positive value, so it will be changed to increase. Okay, increase or decrease depending on the value of B, whether is it positive or negative. Okay, and then the next one asks you to write down the regression equation for the data. So in general, the regression equation is given by y equal to a plus bx, right? Okay, this is in general. So for this situation, you can write the equation. In this case, y is equal to, what is the value of a? So the value of a will be the constant, value. Okay, the constant value is 6.747. Okay, this is 6.747. So you will get 6.747, and then minus, because the value of b is negative, so minus 0.216x. So this will be the regression equation for this data set. Or if you want to write the answers in the form of the given variable, it will be driver age driver's age, but number of accident, number of accident is equal to 6.747 minus 0.216 multiply with driver's age. Okay, so that will be the regression equation line. So sama ada nak tulis yang the first one pun boleh, ataupun nak tulis the second one pun boleh, tak ada masalah. Okay, so that is for the writing down the linear regression equation. And for the last one, you want to predict the number of accidents for a driver who is 30 years old. Okay, so they give you the value of the driver age is 30 years old. So that means the value of x is 30. Okay, whenever you want to substitute the value given, so make sure that you substitute the correct value. Okay, the trick is that whenever you have the given data set is in a simplified form, so you kena hati-hati. Kalau dalam data asal dia bagi dalam simplified form, maksud saya simplified form tu macam mana? So katakan dia bagi number of accidents and then dia letak nombor 2 contohnya, tapi dalam kurungan ada ratus. So maknanya 2 tu bermakna 200. Okay. So when they give you the questions and then they so predict, katakan dia bagi the number of accident is 323. So maknanya 323 tu bila you nak masukkan dalam you punya persamaan, sebab you guna persamaan you menggunakan data yang simplified yang 2 tadi kan. So 323 tu jangan pula pergi masuk 323. So you kena simplify kan juga. Jadi 3.23. Barulah you masukkan dalam you all punya persamaan. So that thing you have to be very careful. Okay, sometimes they trick you in terms of the unit used. So make sure that the unit given in the question is the same with the unit given in the data set. So if it's not the same, so simplify it to make it the same. Okay, itu maksudnya. Tapi yang ni, data asal kita dalam bentuk years, tidak ada simplification. So dia bagi pula data pun dalam bentuk years juga. So you just can substitute the value directly. So in this situation, you can identify straight that the value of x, so given x is equal to 30. So you can find the value of y. So y is equal to 6.747 minus 0.216 and then you multiply with 30. Okay, you kira yang ni teruslah akan dapat dia punya jawapan. So when you calculate this one, you will get 6.747 minus 0.216 and then multiply with 30. So you get this to be 0.267. Okay. Okay. 6.747 minus 0.216 times 30. Itulah. Okay, you can dapat 0.267. Okay, so the number of accident is 0.267. So that means tak sampai 1 lah kan. Kita tengok balik data, betul ke? Betul lah So kat sini dia kata kat sini, so this one kalau katakan umur dia dah 27 ke 30 pun dia almost 1 kan. So that means dia predict dia akan jadi lebih kurang kosong lah. Okay, dia tak sampai 1 lah, dekat dengan kosong. So hampir tak ada accidents. Alright, so that is for the last one, the prediction. So that means the predicted number of accident will be 0.267 accident. So almost 0 lah kan. Okay, tak ada accident lah. So maknanya 30 years old ni dia dah jadi expert driver lah. Dia dah expert, mungkin lah macam tu lebih kurang. Okay, so that is for the answers untuk question number 2 untuk Julai 2021 punya past semester exam papers. Okay, so let's just look one more question. Kita tengok satu lagi soalan. Let me get one more questions. Banyak. Okay, suppose kita tengok soalan yang lama sikit lah. So let's see question 2015 lah So let's say we took 2015. Ada tak soalan berkenaan dengan regression So let's see if they have questions related to regression. Mana soalan regression? Ini bukan. Ini pun bukan. Ini pun bukan. Okay, this one. Okay, this is another question on regression analysis So kita buka besarkan sikit. Okay, it says here a study was conducted to investigate the relationship between base financing rate in percent and non-performing financing in percent in ABC Islamic Bank. The data was collected for 36 months and the result of analysis is shown below. So you have this data set, right? So you have all this value, and then they give you the summation already. So they give you the summation of x, summation of y, summation of x squared, summation of y squared, and summation of the xy. Okay, so dia dah bagi dia punya summation semua. Kenapa dia bagi kat semua summation value ni? Because normally you will need this summation value to calculate all the possible outcome. Okay, all the possible values needed. Contohnya macam you punya coefficient, you punya beta coefficient tadi, and so on. So this is the scatter plot given. So if you look through the scatter plot, you can see that there exists maybe moderate to strong linear relationship between the financing rate and non-performing financing, right? So kalau tengok, you boleh dapatkan satu garis lurus kat sini lah. Okay, if you look through this one, maybe you can just write a straight line over here, right? So you have an increasing or a direct relationship between the financing rate and the non-performing financing, right? So you boleh nampak macam tu kan? Okay, and then they give you the model summary. So in this case, they give you the model summary, but it give you an empty space for R, and then they give you the R square, and then they also give you the adjusted R square and the standard error, and then they give you the coefficients. All right. Okay, they find the coefficient and so on. So this is the actual result obtained from SPSS. You can see that it's already written there. The dependent variable is non-performing financing. So that means the financing rate will be the independent variables, right? So the question asks you, based on the output, answer the following question. The first thing is to identify the independent and dependent variable. So this is specifically dah diberi pun dalam output tu kan. So dah bagi tahu dah kat situ. Non-performing financing is dependent variable. So that means financing rate will be the independent variable. So you boleh tulis kat sini lah. So in this case, you can just write down the answer. Independent will be financing rate, and then the dependent non-performing loan. Okay, so that will be the independent and dependent variable. Okay, by referring to the scatter diagram, describe the relationship between the two variables. So tadi saya terangkan kan. So by looking at the scatter diagram, you can see that there exists a positive linear relationship. So what you can say here, describe the relationship. So you just can say here that there exists a moderate to strong positive linear relationship between the two variables. Ataupun kalau you nak be more specific, you can just write down what are the variables. So you can just say that there exists a moderate to strong positive linear relationship between financing rate and non-performing loans. Boleh juga. Okay. And then kat sini dia maklum kat sini, so calculate the value of R. So you can see here, okay, this is an indicator. So you boleh tengok, so dia katakan calculate the value of R, and you see that the marks here is 4. Of course, you can get the value of R directly from the R squared value. But when you see the question, it says here calculate, and then they ask you, and the marks is very high marks, 4 marks. So of course they required that you to do it manually. Okay, you kena kira secara manual. Okay, you kena kira secara manual lah. So that means in this situation, you have to calculate the R value manually. So to calculate the R value manually, so what you need to do is just simply using the formula. So R is given by summation of xy minus summation of x summation of y divided by n, and then divided by the square root of, so the first one is summation of x squared minus summation of x squared divided by n, and then summation of y squared minus summation of y squared divided by n. Okay, and then you punya answer whenever you calculate this one, so actually you tak perlu calculate pun, you just substitute saja. So you just substitute the value. So in this case you substitute value and then you write down the answer. So answer dia boleh dapat kat mana? So kat sini you ada dah kan. So here you have the R squared value 0.281. So R squared value is actually the square of the value of R. So kalau nak dapatkan value of R, you just take the square root lah. So take the square root of 0.281. So you get 0.530. So you get here lebih kurang 0.53. Okay, you get here to be 0.5301. Okay, so this will give you the value of R. Alright, and then interpret your answer in C. So this will interpret pula. Okay, so sama macam tadi lah. So interpretation sama aja. You can see that there is a moderate linear, positive linear relationship between the two variables. Okay, alright. So sama macam tadi. So sama macam you interpret the scatter diagram, lebih kurang sama. Okay, the next one they ask you to get the value for the slope and interpret. So apa dia punya value of the slope? The value of the slope looking at the table coefficients. So look at the financing rate. So here you have the value of the slope to be equal to 0.805. Okay, 0.805. Okay, 0.805. Okay. Okay, you get here B is equal to 0.805. So what you can say here, so macam mana kita nak explain, for each additional unit dia apa? In this case, kalau tengok data asal, so we have the financing rate in term of what? In percent, right? So the financing rate is in percent, and then the performing financing pun in percent. So you get both in percent. So for each additional percent increase in financing rate, the non-performing financing will increase. Kenapa increase? Because the value of B is positive. By berapa? 0.805%. Habis. Okay, so that is how you write down the interpretation. Okay, and then write the estimated regression equation. So you can write the regression equation. So this is given by y equal to a plus bx. So in this case, you can write here in the form of what is the value of a. So the value of a is simply equal to negative 3.039. Negative 3.039. So negative 3.039 plus. Kenapa plus? Sebab B bersamaan dengan nilai positif 0.805 X. Okay. Alright. And then from C, calculate the coefficient of determination as shown in the output and interpret the meaning. So dia suruh kira pula yang R squared tadi kan. So what you can do is just simply, so coefficient of determination is equal to R squared, right? Okay, this is just simply equal to 0.5301 square. And then you get the answer to be, apa tadi nilai tadi? 0.281. 0.281. And then you need to interpret. So macam mana interpret? So to interpret, you need to change the value here into percentage. So 0.281 is equal to 28.1%, right? So that means the interpretation 28.1% variation in Y. So what is Y? Y is non-performing financing. So that means 28.1 variation in non-performing financing can be explained by the variation in X. So what is X? Variation in X. X is financing rate. Okay, so that is the financing. So that is the interpretation for this part. Okay, so coefficient of determination, you just simply square the value of R and then you get 0.281 balik. And then interpret just 28.1%. So convert the 0.281 into 28.1. Then you will calculate the, then just explain. And finally, you need to predict the value of non-performing financing if the base financing rate is 6.4%. So just simply substitute. So in this case, X is equal to 6.4, right? So substitute in Y. So you have Y equal to, just now is negative 3.039 plus 0.805 and then multiply with the value of 6.4. Okay, so calculate this one. You should get the value to be negative 3.039 plus 0.805 and then multiply with 6.4. So you get 2.113. 100%. Okay, so that is the value of that is the solution for the particular question. Alamak, mana pergi pula tadi? Okay, boleh Alright. Okay, before we end up the session for today, I just want to show you something. Okay, let's go back to the calculation value of the R. Okay, so this is a simple linear regression whereby you only have one variables involved, one variable for the independent variable. When you calculate the value of R, you get the value of R to be 0.5301. Okay, actually this answer is already in your output. Okay, you boleh tengok kat sini. So this value is actually the same as your beta value. Okay, you tengok dekat sini, you punya standardized beta. So this is only applicable for a simple linear regression whereby the standardized beta coefficient is simply the value of R if there is only one independent variable. So you can see that the value here is 0.530. This is the same as the value of R. So kalau you run, memang you akan dapat benda yang sama lah. Okay, you will get the same answer over there. Okay, this is only for kalau katakan you ada satu saja independent variable. Okay, that is the extra information that I want to give you in terms of the how to read the output from the SPSS. Okay, any questions?